So today we are moving on to 8.2, which is estimating sums and differences of fractions. Our learning target for today is to estimate sums and differences of fractions. Our success criteria is that when you are successful, you will be able to use a number line and benchmarks to estimate a fraction. You can use mental math and benchmarks to estimate a fraction, and you can use benchmarks and estimate sums and differences of fractions. Okay, so a sum would be like adding things together, differences are subtracting things, and we're estimating right now. Right now, we're just making ballpark guesses. We're using our knowledge to make a good guess of what the sum, adding them together, or what the difference might be. Okay, so the place we're starting at, it says plot, which basically just means put on. So put 7/12, 5/6, and 1/10 on the number line. Okay, I already have some visual representation here for us to help us understand what that might look like. And now we need to figure out where these numbers go. Okay, so first is 7/12. 7/12. What do we think that would look like? And where do you think that would go on the number line? 7/12 would be right here. Okay, this is 7/12. 7/12 is close to 1/2. This is 1/2. This is 7/12. Sorry, that 12 looks really bad. Okay, so 7/12 is close to 1/2. It's a little bit more than 1/2, but it's close to 1/2. So if we were to round that, we would say that was 1/2. Next, we need to plot 5/6. Think, where would 5/6 be on this number line? Would it be close to 0? Or would it be close to 1? If you said close to 1, you are correct. This is 5/6. We're just missing that last little piece that would have made it 1 whole. Okay. Finally, 1/10. We obviously know where it's going to go because there's only one option left. It goes right here. So 1/10 is very tiny. If you got 1/10 of a piece of pizza and you were really hungry, that would not feed you very well. But if you got 5/6 of a pizza, you would be stuffed. Okay? Whenever these numbers, whenever the numerator and the denominator are super close together, like 5 is close to 6, that means that they're closer to being 1 whole. When they're really far apart, like 1 is to 10, that means that they're going to be a really small number, close to 0. And then if they're like halfway in between, they're going to be half on the number line. Okay, now it says, how can you estimate 7/12 plus 5/6? So we're finding the sum by estimating. So like I said, 7/12 is close to 1/2, right? It's not quite 1/2, it's a little bit more, but we're estimating. So we're going to act like this piece wasn't even colored in and we just see half a pizza. And then 5/6, well, 5/6 is pretty close to 1. So we're just going to say 1. So now we have to think, what is 1 pizza plus half of a pizza? What would that equal? That would be 1.5 pizzas. Okay, now it's asking us, how can you estimate 2/3 minus 1/10? And remember what I said, whenever these two numbers are really close, they're getting closer to 1. So 2/3 would look like this. And you color in this side, and you color in this side. So we have 2/3, which is close to 1, minus 1/10, which is close to 0. So if we were estimating that, that'd be like 1 minus 0. And what's 1 minus 0? Well, it's just 1. If you have one pizza and nobody comes to take any of it away, you have 0 pizzas taken away, you still end up with 1 pizza, right? Moving along. We are now, okay, so it says you've used the benchmarks 1/2 and 1 to compare fractions. You can use the benchmarks 0, 1/2, and 1 to estimate the sums and differences of fractions. Now it's telling us to estimate 1/6 plus 5/8. Even before we can get started, let's just think about these numbers. 1/6. Are 1 and 6 close? No. So we know that's going to be really small. So I'm just going to write an S over it because I know it's going to be small, or it's going to be a tiny fraction. Okay, 5/8. Are 5/8 close? Not necessarily. It's not like it's 7/8. So they're not really close, but are they really far from each other? No, not really. It's not like it's 2/8. So it's kind of right in the middle. 5/8 is right in the middle. So it's not small, it's not big, it's just right in the middle. Okay? So step 1, it says use a number line to estimate each fraction. 1/6 is between 0 and 1/2, but it is closer to 0. We already talked about this. This is small. It's right here. It's closer to 0 on the number line than it is to 1/2. 2/6 would be right in the middle. 3/6 is 1/2. 4/6 is closer to 1/2 than it is to 1. And then 5/6 is closer to 1 than it is to 1/2. But we're looking at 1/6. That is closer to 0 than it is to 1/2. 5/8 is between 1/2 and 1, but it's closer to 1/2. Okay, so right here we have 5/8. That's the number we're looking for. And right here is 1/2. 5/8 is closer to 1/2 than it is to 1. If we had 7/8, that would be close to 1, but we have 5/8, which is close to 1/2. So now we need to estimate the sum. An estimate of 1/6 plus 5/8 is 0, because it was small, plus 1/2, which gives us 1/2. There you go. Next example. Estimate 9/10 minus 2/5. So up here we were adding, now we're subtracting. Use mental math to estimate each fraction. So remember what I said, when these numbers are close together, they will be closer to 1. See, 7 and 8, they're close together, so that means they're close to 1. 1 and 8, they are not close together, so they will be close to 0. 9/10, do you think that will be close to 1? Or do you think that will be close to 0? That would be close to 1. Okay? 2/5. The numerator in 2/5, 2 is the numerator, that's about half of the denominator. So that means that this will be close to half when we're rounding it. So when the numerator is about the same as the denominator, it'll be about 1. When the numerator is half of the denominator, it'll be 1/2. So now we need to estimate the difference. An estimate of 9/10 minus 2/5 is 1 minus 1/2, which gives us what? If I have 1 cookie and I give half of it to Ashlyn, how much of a cookie will I have left? I would have half a cookie left. Okay? So you are going to estimate the sums and differences by thinking about, is the numerator close to the denominator? Is it about the same number as the denominator? If it is, then it'll be close to 1. Is the numerator about half of the denominator? If it is, it'll be close to half. Is the numerator really far away from the denominator? If it is, it'll be close to 0. So you're going to be estimating 0, half, and 1, and then adding them together or subtracting them, finding the sum or finding the difference.